So I don't really do these videos very much anymore because I feel like I've said most that I can say about power supplies, but uh, I do still get the question once in a while, which power supply should I buy? Is this particular power supply a good one? And today I'd like to walk through a little bit of the process, whether a power supply is good or not. So this is an AC to 5 times USB power supply from apparently Goobay. Um, so, well, the first thing you can do when looking at a power supply is looking at all the external stuff. These days, even crappy power supplies can have decent build quality. And this one, it weighs a little bit. It's fine as far as the subjective build quality is concerned. All the tolerances are reasonable. There is no real, I don't see much at fault with it. But on the sticker, we can see that there's a lot missing. There's only the CE mark on there, but that's all there is. There is no UL marking. There's no external verification. CE marks can be self-certified, so this is pretty bad as far as certification goes. It's only for indoor use, and it's kind of interesting. It says intelligent multi-port charger. Okay, so far so good. White, it sure is. 1.5 meters. Okay, because that's the lead that is supplied with it. I got it without a lead. And 8,000 milliamp hours. That's usually like that's a measure of energy, not of output. So this is an 8 amp combined charger, and we'll probably see all the output ports not actually individually limited to 2 amps or something, but they're all paralleled up, and you can most likely get 8 amps from just one socket. The fact that there is this kind of error on the back also is a bit of a red flag. It's probably not very good quality, but we'll see. So the really cheap devices usually are ultrasonically welded, and no, I shouldn't actually say that. They are not necessarily ultrasonically welded because they are cheap, but to keep prying eyes out of it, because there's really nothing serviceable inside. But this one has little screws under the feet. So I've undone the screws, and yes, there is no other way to gauge the quality of a power supply other than taking it apart and looking at the insides, because yeah, from the outside there is no saying if it's a counterfeit. Now the next thing you can look at is the inside plastic quality. So does it look like a decent type of plastic? And in here, I'm not sure if this will register on camera, but it says PC, so that's polycarbonate. There is no glass fiber filling, but polycarbonate is a very impact resistant, actually a relatively high value plastic. It's also very easy to get the good finish on it. So that is a relative mark of quality as far as that goes. And the next mark of quality for any power supply is the fact that they use FR4. So that's the PCB material. So if the PCB is green and not yellow, that means it's most likely FR4. It's even more of a mark of quality, well, a mark of expense at least, if the PCB is multi-layer, but I don't think this is. Now, unfortunately, I don't have my macro lens with me, so you'll have to just trust me on this one. Sorry, I didn't expect to do this today. More marks of quality. There's a primary and a secondary side. The primary side is the side with the AC socket and all the high voltage stuff, and the secondary side is here. And between the primary and secondary, there should be decent isolation. So what they usually do is either they just make sure that everything is far apart enough, and if they can't, they put in slots. So here is some isolation. Here's an optocoupler that does the feedback, and that has an isolation slot under it, and it's decent. Everywhere you look, there's at least 6 millimeters or even 8 millimeters of actual distance between anything on the secondary side and anything on the primary side. Now, a second mark of quality for power supplies is the fact that they have feedback. We're really at the bottom of the barrel here, but if it doesn't have an optocoupler, then the secondary side is pretty much unable to regulate itself very precisely. And it does. In fact, as I can see, it has a lot of good features. So here on the outside, here is a current sense resistor. You can tell because it says R010. That means it's 10 milliohms. The only reason to ever have a 10 milliohm resistor is to do current sensing, pretty much. That means it is current limited. And indeed, everything is paralleled up. But we can see that there is a little device on every port. This is most likely not a current limiter for each port, because what I think is going on here, there are resistors that can be on each port that maybe so these devices, these little black devices on each port, these are necessary for negotiation. So if you put in a phone in a USB socket and there is nothing going on with the data lines, then the phone assumes it can only draw about 500 milliamps. It is connected to a regular USB port or something, and it doesn't have like dedicated charging capability, so it will default to a safe value like 500 milliamps. If a phone is to be charging faster than that, you have to do something. You have to put certain voltages or resistances on the data lines, and that's what's happening here. That's this little device. This is very, very standard on USB chargers. Now this resistor here probably pairs up with a device that is not mounted. If you look very closely between the ports, there are footprints for a 5-pin SE70 device, and those are most likely current limiting devices for each port that work together with this with these resistors, these very large footprint resistors, which are most likely current sense resistors. So it doesn't do any per port current limiting, but it does have negotiation, as it should have. So these ports are indeed all paralleled up, and I can probably pull 8 amps out of one of these ports, which is over the limit of this connector, but I'm not really faulting it too much for it. Now there are more marks of quality. So this white Goobay material, you can see that's elastic. It's a silicon elastic material. That's why I call it silastic. This is used to stabilize different elements. So if you drop this, you can probably guess that things like this big capacitor and well, anything that kind of sits on very thin legs will be able to vibrate, and eventually that vibration will cause the solder legs to snap, or the actual solder connections to snap. That can cause sparks and cause a dangerous situation. So you want to stabilize everything, and they put this goop everywhere. And if it's this kind of goop, that's pretty good. If everything is actually well stabilized, and we see some marginal examples here, but this is really just fine. I would have liked a little bit more silastic on this AC coupling ceramic, but yeah, whatever. This is all fine. Now, if you really expect a high quality power supply, then the last thing you look at is the capacitors. Both the primary high voltage capacitor, this one is a WT brand. It does say -42 plus 105C, which is a good rating, but I don't know this brand, and it's probably a pretty crappy brand. But the primary, the big cap, really doesn't matter that much. What is much more important is the secondary caps, and there are 3 here. That's not a lot, honestly, but let's see if I can tell what the brand is. No, it's also a WT brand, so it's a pretty crappy brand. So this is like altogether, it does look like a decent transformer. It is certainly large enough to output 5 volt 8 amps. Construction is very decent, good quality PCB. There's no modifications on the board. The solder quality is good. There's well, it's reasonably thought out. Safety is good. Caps, kind of a minus, kind of a negative point, and also these caps are mounted to this heatsink for the secondary rectifiers, and the secondary rectifiers are certainly the part that get the hottest. So this is probably going to be an issue in the long term. You're probably going to get much more ripple over time, especially if you load it aggressively. But for light loads, it will last a long time. And then another, not even a mark of quality, but just the absolute minimum, is can you see any input filtering and input protection? And we can. This here little blob, this is a fuse. It says 3.15 amps. That's decent, that's fine. There's a little common mode choke, a capacitor, another choke, and then here is the bridge rectifier, which is again set right next to the primary capacitor, which is also very adjacent to this heatsink. So as far as like they did put this plastic thing here to insulate the primary and secondary, but yeah, this is gonna get hot, and eventually this cap will fill and these caps will fill. So in the long term, you will probably want to replace these caps with brand name caps, probably this one as well in this case, just because of the bad situation it's in, and to get like really long life even at higher loads. But otherwise, this is a very decent quality power supply, and I probably would recommend it to people if they are specifically looking for something that can output 5 volts and like more than 3 or 4 amps.